Alright, so in this video I'm going to go through the whole counting primes problem, and to start off I'm going to go ahead and read off the problem statement, and that is this: given an integer n, return the number of primes that are less than n. So what does that mean? Let's say I have an input. I'm going to get an input of an integer, and let's say 10. I'm pretty much going to have a range from 0 to 10. And then I'm going to have to output the amount of primes in there. So for this example, it's showing me that the prime numbers are 2, 3, 5, and 7 when I have a range of 0 to 10. And so that means I'm going to be outputting, my output will be 4 because there are 4 prime numbers. So kind of getting that out the way, uh, I'm going to go ahead and jump in to the explanation, and I want to state off the prime number rules so when we go through the explanation it's not necessarily that confusing, but it's just to kind of lay things out straight. So to start off, prime number rule number one is that prime numbers start with 2, and that prime numbers are only divisible by 1 in itself evenly, meaning that 2 2 is one of the prime numbers. There's nothing in that test case that is evenly um, that can be evenly divisible besides itself and 1. I know in a way that 4 and all that can work out, 4, 6, 8, but we're focusing on strictly that number 2 example that I gave you, meaning that it's only divisible by 2 and divisible by 1. So start off is our understanding portion real quick, and I already stated it out. We will have an input of an integer. This will be like our range number, and we're going to be outputting an integer. And this is going to be how many numbers there are. So right off the bat, I'm thinking about what I'm using. Thinking of a list that comes to mind. I'm going to be using a list for sure, and maybe a counting number, but I think we're probably going to hold off on that in the meantime. But let's go ahead and go into our matching portion. So what's matching? Matching is previous problems that are similar to what the problem is stating. And right off the bat, I'm thinking of my FizzBuzz problem that I've done here. And FizzBuzz, why FizzBuzz? Because in the FizzBuzz problem, I am checking to see if a number that is, I'm going to be inputting a number and outputting either a stringer or an integer. So let's say for this one, 1 to 10, I am going to be going through, well, I'm going to be inputting the number 10. I'm going to be going from 1 to 10, and I'm going to be checking if that number is divisible by either 3 or 5 or both. And depending on what it checks off, I'm either going to print FizzBuzz if it's both are yes, Fizz if it's 3, divisible by 3, and Buzz if it's uh, divisible by 5. Otherwise, just jump straight down to the number and output that. So it's something similar, and that's kind of the only thing that I have into mind. So that's at the moment what I have. All right, and a quick breather. All right, so what's our next step? So FizzBuzz, only thing I think of next step is we're going to go through the planning portion. This is where we start to build our skeleton of our code. So in the planning portion, of course, first step. I already know that I'm going to be having an input of an integer, so let's start that off. I'm going to get an input of, let's take an input of int, int. Alright, next thing, I know I'm going to be working with lists, and I'm going to be having a list where I'm going to declare an empty list, so let's just say this empty list, let's call it prime nums. we are going to declare that as empty. So I'm going to have that there for the pseudocode. I'm going to try using pseudocode for the blending portion so we can kind of see what we're working with in a visual way. So, alright, now, here is where the first rule comes in. Okay, and that is we want to go ahead and take our integers. We want to go ahead and, we want to take in our first rule. So our first rule is that prime numbers start with the number 2. So anything less than 2 is just not valid. So we want to check that when we take an input of it. So let's real quick up top, let's actually just give it a name. I'll give it num. Let's give it num. So starting with our if statement, if say num, right, is less than 2, this is something that's going to be pretty useful. We want to have our list still be empty. It's important that we have it empty because that means that when we check our length of the list and it's empty, it's going to be down to 0, which is what we want. So this is what we're going to be working with. Now let's jump on to our next one. So what? Because every number above that is going to be valid, meaning that we can actually go through. So if it's 2, we have 1. If it's 3, we have 2 numbers. So let's go into it. Now we have that. We need to first append our numbers, right? So let's go ahead and do it. So the way we append it is we would have a for loop. We would have a for loop that appends each number. Now already I see an issue here is that we can't have each number. We can't, the rules above where it has to start with 2. So we have to do a little math where, let's say I, so let's say for I in, what was it, num, right? Or let's do range. Range would have to work out. So range would have to take it from 0, 0 to that number before it. So if it's 10, it would go from 9. So if it goes from there, that means that, okay, I actually want to, so 0 and 1, that's 2 numbers I need to take care of. So this means that I have to go ahead and remove 1 number, so I would have to do for I. So let's say our number is still 10, so this means that it would actually input from 0 to 9. I want to subtract another number, so that means I'm going to go from 0 to 8. Sweet. But how will I solve the problem with having 0 and 1 taking out? Well, the I is actually supposed to be lowercase. We're actually going to go ahead and have, let's first start off with our appending portion. So we would have, say, list, append, and that's going to be I. And again, if we're down 2, that means we have to add 2. Again, let's fix that I up. Alright, so let's take a quick moment to see what I did here. So for I in range, num. Again, I want to take the example that num is equal to 10. So 10. So when we use range, I'm using it from 0 to 9. That's already one number that, like, by itself without it being altered yet, that's going to be the situation. But we don't want that. The issue of that is that we have 0 and 1 at the starting. We want to get rid of that. So the way we do it is we actually subtract num an additional time. So instead of 0 to 9, we have 0 to 8, which is perfect because that means that our second step is I plus 2. That means is that if you look at the math, is I'm going to kind of explain it real quick, is so I plus 2. So 0 plus 2, 2. Perfect. 1 plus 2, 3. And that's what we're going to be appending. So let's actually do a little mini thing. You know what? Yeah, I plus 2. That's what we want. I plus 2 because that means it's going to jump 2 numbers beyond it. Beyond 0. 2 plus 0 and so on. So we're always going to be getting every number after 1. So that's what this portion does is uh, this first section of our if that I've highlighted, what that does is it rules out the first prime number rule. And that is that prime numbers have to start with 0. Start with 2. Yeah, so that's how we would go. Now, the next part. What do we do here? Alright, we have our numbers. So now what? Well, we need to now find a way to check our second condition, our second rule. Prime numbers are only divisible by 1 in itself, evenly. Now, okay, what gives? What do you mean by that? So divisible, that's where we would use our divisible operator, the percent sign. So that we're going to have to get through, but we need to create a nested loop when we're checking each numbers with itself. And let's go ahead and do that. So for A, being the first row, for A in prime nums, and then down here, we're actually going to do for B in prime nums. So we're pretty much doing like a cross of each other. So we're pretty much just checking it by itself. And it's good because that means that we can now move on to the next portion. Because I am checking to see if a number A is being divisible by each of the numbers, we need to make sure that it's divisible by itself. We need to remove numbers that are evenly divisible. Like that are just more than itself. So let's see how we would do this here. So let's see here. So if B is divisible by A, this means that we're going to start off with A. So I don't know, again, it's going to start off with 2. If, let's say 2 is, we need to check if it's evenly divisible. So let's say, for example, if 2 is divided by 2, is divisible by 2, it is. There's no remainders there, so we would move on. And we would have to remove 2. That's a problem. It can't have it be removing itself, otherwise the whole system breaks. So, how do we check that we don't do that? That we don't accidentally remove our number that works? Well, we check if A is not equal to B, then what's going to happen here is that we're going to go ahead and take our prime nums and we're going to go ahead and do our remove method. And we are going to get rid of B. Why B and not A? Because A is the number that we are like checking. Like that's our key, kinda. That's our key that we're checking to make sure that, or kind of like manager, or like the standard. It's like the uniform thing that we need to make sure that every number that we're looping, which is B, we're going through the whole thing. That is B, is being checked that it's equally divisible by 2, for example. So 4, in this case, 4. 4 is a number that's not a prime number because it's not just divisible by itself and by 1, but it's also divisible by 2 evenly. So that breaks our rule. So that's what we're trying to filter out here, is that 4, let's say 4 for example, is what we're checking by 2. 4 divisible by 2 is 0. That is true. So we jump here. But are they divisible? But are they the same number? If it's not the same number, perfect. That means we found our non-prime number and we're removing it from our list. And that's essentially the whole point of this, is that we're constantly doing this over and over and over until we're just left with our last number that is either being removed or being stayed. Alright, cool. So what comes next? Well, it's actually going to be quite simple. We are going to go ahead and print our list length. and that's it. So if it's empty, so print length prime nums, an additional one because we're checking the length while printing that out. Yes, that's pretty much how we're gonna go here. Yeah, that's pretty much it. That's kind of how our plan is gonna work out. Now, because I did write this in code, I am not gonna kind of fix that all out. It's pretty much what would be the actual implementation is the planning at this point, where we would have we would take an input of a number. We call it num. So maybe even just fix it up a bit to make it cleaner. So num equals, and we'll concatenate it. Concatenate it. One of those words is probably right. And then we're going to input it. So we're going to concatenate our input being an integer. We're going to declare an empty list, and we're going to check the two conditions, whether if it's less than 2. Otherwise, go through this little algorithm that we made that is going to be appending that's going to be removing. That's going to be, excuse me. It's going to be appending every number starting with 2 up to num. And then we're going to go ahead and we're going to start removing numbers that are not prime based on this nested for loop. Then we're going to go ahead and check down here and see if it's divisible. If it's divisible, all right, cool. Are they the same number that are evenly divisible? If they are not the same number, remove it. But if it's the same number, like 2 and 2, keep it. We're going to jump to the next part, and that's going to be 3. 3 divisible by 3. That's true. Keep it. All right, jump. Because we got rid of 4. Cool. That means it's going to jump over to 5. 5, it's not divisible, so it's going to loop back to the next number. 6. 6, is it divisible by 3? Yes. Are they the same number? No. Remove it. Remove number 6. And that's the whole cycle. Up to a point that we should get that. So, the code here makes sense. It's going to work because it's not an IDE. I can't really show the actual coding method of it, like it working. But I can definitely say that this part up to here will work. This will work. This should work because we are checking it, and the math, and because we are following the prime number rules that were stated. So that would be the end of this video here, and I will go ahead and leave that be. I'll leave it here for a quick second for you guys to look at it, and that is the end of the video. Thank you.